ACN, you know, we calculated, you get minus 64I, right? Now we have to include the normal and the tangential plus by 2J. Can you remember where we get the 64, right? We get the 64 from here, right? We got the 64 from here, okay? And then plus by alpha, okay? So alpha over here, what did we get alpha as? Alpha is equal to what? 10, okay? So alpha is plus by minus 10K cross RB from point C, okay? No, I think I got that. Yeah. B from point C. So it's because the radius is 0.25. Okay, so it's 0.25I minus by 0.25J. Okay. Then we have minus by omega squared, 16 squared, multiplied by 0.25I minus 0.25J. Okay. So I and J. So C, point B from C, positive. Yep, we are good. Okay. So then we can formulate AB tangential the I plus by AB normal J. This is equal to minus 64I plus by 2J. K cross I is positive, so minus 2.5. So 10 times by minus 2.5 minus 2.5J. Okay. K cross J is negative, minus 2.5I. 16 times by 2.25, 16 times by 2.5 is minus 64I minus plus by 64J. Okay. Okay. So from here, we do the I component. So with the I component, you have minus ABT, and then this will be equal to minus 64 minus 2.5 minus 64. Okay. 64. Go on. Point C, this is positive. I beg your pardon. Can you do the ACN should be positive. I put negative is wrong. Okay. Positive. So AB in the tangential direction is equal to what? 2.5 feet per second squared. Okay. So the J component comes in. So you have ABN is equal to 2 minus by 2.5 plus by 64. So this is equal to 2 minus 2.5 plus by 64 is equal to 63.5 feet per second squared. Okay. So it's not equal to 64. It's 63.5. Some will be like, wow. So if we are going to calculate the true point, if we are going to calculate the magnitude, okay, AB in fact is equal to what? is equal to 2.5 squared plus by what? 63.5 squared. Okay, so 2.5 squared plus by 63.5 squared, square root is equal to 63.54 or 55. And then if you're going to code this value, you need to know the orientation, right? We know that the orientation is doing this. So this is our, no, this is our ABT or our AB tangential. And then our J is going up this way, right? So this is our A, B, N. So what we have calculated is this value over here, which is our AB. And then we want to calculate this angle over here. Okay. So therefore, tangent theta will be equal to ABN 63.5 divided by 2.5. So from here, theta is equal to 63.5 divided by 2.5 inverse tangent 87.7 degrees. And then you have to draw the vector this way, okay? When you, so this is our theta. So if we were to go back to this question over here, is the answer correct? Spot on. Okay. We can do that because all the points are on a what? Single rigid body. Yes. Because ACN, right? They are opposing one another. So if you look at, they cannot move in left and right. Yeah, so if you look at the concept of acceleration, right, will affect mass, right? You have a force, right? We lock it in, we don't allow them to move left or right. But this wheel can go what? Up and down. I should not be like doing this to you because now we are combining what? 2P and what? 2Q, and it's not fair if an exam questions or test question comes out there. But I'm doing the worst question as usual. But that explains to you, right? Why 64 on one side, 64 on the other side is fine. There's a reason. Now, Ryan say acceleration at point A. So I like Ryan's right? I like Ryan's hypothesis. So we, oh, this is a very dark area, but I like it. So if we are going to guess, okay, I think Ryan, I think he is correct. Okay. If I'm going to guess, okay, no, I dare not guess, okay, I'm just going to do it, okay. So we know the magnitude has to be what? 0.5, right? Because at the circumference, it has to be what? 64. Okay, if it's not allowed to move. So point C and point D, they're not supposed to move. Yeah, we get 64. But because point B, right, there's a freedom to go what? Up or down, right? Up or down because it can go up or down, right? This is the motion, right? So it will affect ABN in the J direction, right? C and D cannot move left and right because the rack are locked. Okay, that's the reason. Okay, so this is an extended question. So find A at point A. Okay, so we in fact we have, I think we have all the values. Wait, do we have all the values? Yeah. Okay, so we're going to find A at point A, and we are going to use A at point D. Okay, just I just pick any point down here. Okay, because they are all on a rigid body, it should work. R A from point D minus by omega squared R A from point D. Okay, and at point A, it's at the where? Is at the what? Is at the center, right? So I'm going to assume that it's going up. Okay, so A at point A. Okay, I can be wrong. I don't know. Okay, I'm going to assume that it's going what? Up. Okay, so A at point A. So we know that at point A, we only have minus A or minus A at point A, and this is in the J direction. No, plus, because I assume it to be going what? Going up. Okay, so this will be equal to minus AD. So ADN I, because it's going towards the right, right? Right. And then we have minus 3, right? Minus 3. Minus 3 AD is 3, right? So 3, is it 3 or 2? 3, right? So minus 3, this is 3J, right? Plus alpha over here, we have determined our alpha. So our alpha is what? What is our alpha? 10. Okay, so minus 10K cross. So R, so D, okay, point A minus 0.25 I. Let me see. So D to A, so D is a reference. Okay, minus by omega squared. Omega is our 16 squared. Multiply by minus 0.25 I. Okay, so I, so D to point. Yes, we are good. Okay, so this is J minus by ADN is 64I minus 3J plus K cross I is positive, so this is going to be J also. So 10 multiplied by 0.25. 2.5. So 2.5 J, right? So minus by 16 squared. So 16 times 16 times by 0.25 plus by 64J. No, 64I. Okay. So J component, so AA is equal to minus 3 plus by what? 2.5. So minus 3 plus by 2.5 is, hey, minus 0.5. There you go. Okay. So this is your feet per second. But because, why is minus down here? Because I guessed wrong. So this will be coming down. Right? So when it's wrong, you just cancel over here. So this is, the acceleration is coming down by 0.5. So this is equal to 0.5 feet per second, and it's going down. Come on, Eugene, wake up. So you answer the question, yes. Say it again. Average acceleration. Then you divide by 2. Yeah, don't do that. I'm scared. Okay. I mean, you can't just add up something and divide by 2. Okay. I'm fearful. Okay. I'll tell you why I'm fearful. I've not done enough question to say that it's yes or no. Okay. This course I just started teaching this year. The last time I taught it was 2018, 17. So I need to do more questions to answer you yes or no. Okay. But don't try that. Okay. Very, very risky. Are we clear? Okay, don't go there. Yeah. I know the logic say yes, but logic and physics and math are very different. Okay, you agree or disagree? I'm not saying that you are wrong or what, okay? I can't shake my head down unless I try more examples. I will hunt more examples and I will tell you, okay? Right. So what I want to inspire you on this is, when you look at the solution manual, don't just like, okay, I'm going to memorize this, and this, okay? Don't do that, okay? Right. So the next question is one of the worst. In fact, list the worst. And if you can do this question, you are the master of the universe. Okay. Okay. This question tests a lot on, I know. Okay, you know what? I'm going to stop here. Okay. And I'll see you on Monday. Okay. Go. I know. On a I know on a Friday.